Dear students, myself, Dr. Mallikarjun S. Biradar, Assistant Professor in Mathematics, Government First Grade College, Basavakalan. Today, we are going to discuss the second session of Graph Theory 2. The title is Eulerian Trail, Eulerian Cycle and Eulerian Graph. So, before we discuss about Eulerian Trail, let me recall the previous concepts what we discussed in the fifth semester. What is a walk, trail, path, cycle? Okay, you know already all those things. Let me recall. What is a walk? You know already walk is an alternative sequence of vertices and edges. Okay, in that trail is also a walk. Trail is also a walk in which no edge is repeated. So please remember this in your mind. What is a trail? Sorry, I am not saying about Eulerian trail. Simply I am saying about trail. What is trail? Trail is a walk in which no edge is repeated. It implies there may be repetition of vertices, but edge is not repeated. So let me take one example to clarify what is a trail. I will consider one graph. Okay, so let me label the vertices V1, V2, V3, V4, V5 and edges E1, E2, E3, E4, E5. So I have considered one graph G. So what is a trail? Trail is a walk in which no edge is repeated. I will start my walk at V1. Okay, so now I will start my walk at V1. So I come to the vertex V2 by tracing the edge E1. So V1 to E1. So this edge. In this way, I shall move to V3 and I shall move to V4. Then I may come back to V2. Here vertex is repeated. V2 is repeated. So no edge is repeated so far. Then I will reach the point V5. So I have started at V1 and ended at V5. So this is a trail in which a trail is a walk in which no edge is repeated. Once again, we have started our walk at V1. In this way we have traveled, and this way like this, like this, like this. So we have started at V1 and ended at V5. V2 is repeated but no edge is repeated in this walk. So such a walk is called a trail. Okay, and a trail is said to be open. A trail is said to be open if starting point and ending points are different. Here we have started at V1 and ended at V5. So it is an open trail. It is an open trail. So what is the closed trail? Let me take one more edge. Okay, so now I will start at V1. Again it is a trail. I will start at V1. So in this way we will reach at V2, at V3, V4, again V2, V5 and V1. So we have started our walk at V1 and we have completed our walk at V1 only, in which no edge is repeated. All edges are distinct. So vertex, there may be repetition of vertex. Okay, so such a trail is called a closed trail. So we come to know, or we have clarified what is open trail and what is closed trail. Okay, now think of Eulerian trail. Eulerian trail is an open trail. Eulerian trail is an open trail, or you can say an open trail containing all edges of the graph. An open trail containing all edges of the graph is called an Eulerian trail. Is it clear? So what is Eulerian trail? An open trail containing all edges of the graph is called an Eulerian trail. So I will consider the same graph by deleting this edge. Now this is an Eulerian trail. What is an Eulerian trail? It is an open trail containing all edges. See, this is an open trail containing all edges. So such a trail is called an Eulerian trail. Is there any doubt? I think it is very clear. An open trail containing all edges of the graph is called an Eulerian trail. So this is an example of an Eulerian trail because this is an open trail containing all edges. We have not neglected even a single edge. We have considered all edges. Okay. Now, as I said, open trail and closed trail. Now we come to the definition of an Eulerian cycle. So Eulerian cycle is nothing but it is a closed trail containing all edges of the graph. What you can say? It is a closed trail containing all edges of the graph. For example, so this is an example of Eulerian trail. Okay. Now I will consider another graph G2. Same graph. Just what I will do? I will add one more edge. This edge. So it is V1, V2, V3, V4. Next, this is our V5. Let us think of this. Of course, if you want, you can label the edges also. E1, E2, E3, E4, E5 and E6. So it is a closed trail, or you can say it is a closed trail containing all edges. So we start at V1. So like this, this one. So like this we have reached at V2, like this. So it is a closed trail containing all edges of the graph. So such a trail is called such a cycle is called Eulerian cycle. Is it clear? A closed trail containing all edges of the graph is called an Eulerian cycle. Okay, so this is the definition of an Eulerian cycle. Next, what do you mean by Eulerian graph? So very simple concept. Eulerian graph. A graph containing Eulerian cycle is called Eulerian graph. Any graph which contains Eulerian cycle is called an Eulerian graph. So this is an example of Eulerian cycle. Eulerian cycle. Okay, so G2 contains Eulerian cycle. So any graph which contains Eulerian cycle is called Eulerian graph. So therefore, we can say G2 is an example of Eulerian graph. So very simple concept. So what we have discussed today, first we have recalled what is a trail. A trail is a walk in which no edge is repeated. And a trail is said to be open if starting point and ending points are different. And a trail is said to be closed if the starting point and ending points are same. Okay. So therefore, what is an Eulerian trail? An open trail containing all edges of the graph is called an Eulerian trail. A closed trail containing all edges of the graph is called Eulerian cycle. And any graph which contains Eulerian cycle is called an Eulerian graph. So this is the concept I think we have cleared about Eulerian trail, Eulerian cycle and Eulerian graph. Okay, if you want you can consider some more examples. Let me clarify. We are considering some more examples. Okay, so let me think of some more examples. Let me consider another example. You can consider any example of your choice, or you can consider some other examples also. So just think of this graph. Yeah, here it is. Duster. You can consider any graph of your choice. It's not compulsory to consider the same graph which I have drawn. Now, the question is whether this graph is it an Eulerian graph is the question. Okay, consider this as a graph G. Okay, now you can label the vertices V1, V2, V3, V4, V5, V6, V7, V8, V9. Okay. Now, whether this graph is it an Eulerian graph or not? So, when we will say it's an Eulerian graph, this graph is said to be an Eulerian graph if it contains an Eulerian cycle. So, what is type cycle? Eulerian cycle? A closed trail containing all edges of the graph is called Eulerian cycle. So, let us think whether this graph contains Eulerian cycle or not. So, we start at V1. So, this edge we have considered. Next, this edge we have considered. Now it is your choice. If you want, you can move like this. Now you can go like this way. Now we can come in this way. So we have reached at V7. Now in this way we can reach. Of course, repetition of vertex is allowed, but there is no repetition of edges. Now you can come in this way. Again, you may reach at V3 because repetition of vertex is allowed. Now you may come to the starting point also, no problem. Okay, but edge is not repeated so far. So in this way, next, in this way we have reached at V9. Now we can reach V9 to V1. So therefore, this graph contains a closed trail, or you can say it contains an Eulerian cycle. So therefore, this graph is an Eulerian graph. Is it clear? So this is how we have understood the concept of Eulerian trail, Eulerian cycle and Eulerian graph. In the next session, of course, definition we come to know what is an Eulerian graph. So what would be the characterization of an Eulerian graph? After drawing and after checking or verifying whether it contains an Eulerian cycle, then you can say it is an Eulerian graph. But without checking whether it contains an Eulerian cycle or not, just what would be the characterization? Just if you observe a graph, is it possible to say whether it is Eulerian or not? So there is one important characterization for Eulerian graph that we are going to discuss in the next session. Thank you.